O1 is the worst model ever. Look at this. It can't even beat GPT-4o. Why are they making things worse? O1 preview, better. O1 preview, better. O1 preview, about the same, slightly better. Claude on coding, better. Look at this. O1 preview, better. Why is it so terrible? O1 is clearly the best model ever. Look at these metrics right here. Bam! Getting so much better in math and coding and science. Wow! It's clearly the best model. Why would anyone ever question it? Look at this metric. It's also better on language. So it's better on language and math. And Sam Altman definitely said that it is the best model ever, and he is always telling the truth with no bias. Hi, this video is about O1 and benchmarks and AI truth. Really, the whole purpose here is to take a step back and decode the evals and the benchmarks and get the story, the meaning behind the numbers. And as you saw with that intro, depending on how you want to look at it, there's fodder for people who are hating on AI, and there's fodder for people who are saying it's going to be AGI God next year. And so I thought, I don't see a lot of discussion on, like, what do these evals really mean? I think we, as humans, we want to have a single answer. We want to have a single line of this is 37 and this is 42, and therefore the 42 is better than the 37. Unfortunately, that's not how things really work. So let's actually take a look at evals and what they really mean. So first of all, they're not meaningless. So if you say, oh, evals mean nothing, that's not correct. And I've got an article I'll link to here that we can go through some of the specifics of what each eval means and comment on those individually. But they're also not full meaning. There's no set of evals or benchmarks that will tell you everything you need to know about the truth behind AI and where it's at and what's going on with it. All right, I think as humans, again, we have a desire for simple numbers. And this shows up in so many places where people take advantage of it. Politics, for example. But that is just not how reality works. I've spent a lot of my life personally and professionally trying to get meaning out of data. And this is not just in the evals and the benchmarks, again, with politics, with all sorts of other data. As humans, we want to boil it down to the simple numbers, and sometimes that can be useful, but it also can be extremely misleading, especially when certain people use the benchmarks in ways that are to serve them, and they ignore the benchmarks that don't show what they want to be shown. And I'm going to try to get to the real bottom of what matters and what doesn't matter, and how to decode them more broadly here within the context of what does this mean for O1. So I think Chatbot Arena is probably my favorite. I think it's broadly one of the best benchmarks, but even that doesn't fully explain everything. There is a very small subset of the human population that will actually use that, people who are in that want to do that. And so that it's not a full representation of all the different ways in which AIs move forward. It specifically also does it within a frame of chat, which is not all the things that LLMs can do. Again, with numbers and distributions, this is probably one of the most common issues I see. This shows up in life in so many different areas. People see the numbers going up and to the right, or I guess maybe for you it's up and to the left or whatever, and they just expect it to be linear, straight line in that direction. But the reality is that pretty much every distribution in life is nonlinear, and that it is not a straight line. It can appear to be straight lines over short periods, but in general they're curvy. You know, when you study, I think like applied physics or mechanical engineering or anything that involves like the actual math of the real world, you see this over and over and over again. There is not a straight line, and this is true for LLM evals, just as it's true for a bunch of other things in the real world. So each eval is measuring a very thin slice of meaning. Let's actually, before we dig into that, this is a really good article that was written recently. Thanks, Anita. This is a good article that discusses the different benchmarks. And I'm not going to go too deep into each one, but let's just talk about them overall. And this is where people tend to like aggregate these. And again, each one of these is just a small slice, and it itself has major issues, which we will discuss. MMLU, this is multitask accuracy. This GPQA, reasoning capabilities, Python coding tasks, math problems, the ability to model the call functions and tools. I should shoot a whole video on that because I don't think that's how you should be using these. I think that this should, when you write these custom, sidetrack, when you write these custom in the ways that we do it, I think you can get much better results versus depending on like the model to like tool use in models. I think, and I should shoot a whole video. If you want me to shoot a video for that, put a comment below and I'll shoot a separate video on how you can get much better performance with a better framework. Multilingual capabilities. And so the idea is that, oh, well, people think, okay, we measure these, they mean something. If you score really well on all these and you aggregate this, great. That means you're a great model. So I guess we go LLM leaderboard. There's a variety of different tasks here. This is great. OpenAI 01 looks pretty good on that, on the best coding. It's very comparable. I think Claude Opus 3.5 Opus is supposed to come out soon. Math, it's definitely kicking some serious butt there. Let's take a look at Chatbot Arena. GPT-4o, it doesn't have a 1 on it. These are pretty razor thin margins, as I'll talk about here in a second. But each one of these, and I gave this metaphor in another, and I'm gonna give some more metaphors that I think are really useful to, and I'm approach this from many different angles, and hopefully this will help you understand the truth behind these as we dig into more of what this really means. So each one of these is like saying, this is the bottom of an elephant's foot. So this is an elephant. Does this describe all things that have to be described with an elephant? Absolutely not. It's not even close. If this is all you ever saw of an elephant, and somebody said, here is an elephant, would you understand what an elephant is? The answer is no. And it's actually much, much worse than this, because I think that there's really 10,000 plus different dimensions. So we're looking at here, we're looking at 6 different dimensions. We're looking at 3 different dimensions, okay? Even if we were to assume that these benchmarks were very, very good and completely accurate and were flawless, we're still only looking at a very small slice of how these models work and what they can do. I think it's 10,000 plus dimensions, and we're gathering only a small handful. Now, that small handful does have meaning, but please, please, please do not think that just because this model gets bigger or it goes higher on the numbers or it does the PhD math, oh, it's better than humans. There's such a small slice of measurement. I think a lot of what we're getting here, especially with, and I have some more stuff on memorization. Maybe I'll skip ahead. One of the issues is memorization, and I'll circle back around to that. Feynman's Brazil experiments. If you don't know who Richard Feynman is, he's got a really great book called Surely You're Joking, Mr. Feynman. Awesome book, just super fun from all sorts of different angles. And there's an experience in there that he has where the people in Brazil are, at the time that he goes and visits there for, I believe it was a couple of years, and at the end of his time there, he gets in front of the science, they ask him to make a talk, and they don't know what he's going to say. This is very Feynman-like. He says, there is no science being taught here. And basically what it comes down to is that they are memorizing facts without actually understanding or thinking about it. And I think that is a lot of what these tests show, is that they are regurgitating facts without actually understanding it. I think that's a really super on point example for what is happening with these models, and and actually this is a lot of what the tests measure. And so this is similar to what happens in school a lot at Brazil, and not just in Brazil, all over the world. I think they've fixed this since then, or gotten significantly better, because they started to realize he was right. Which is that they're instead of, you can memorize all the different possible physics questions that you could get, especially if the teacher isn't careful, or if you kind of know the test types ahead, and mechanically go through and answer the questions without actually thinking about it. But what Feynman showed was when you throw even just the slightest curveball in there, it demonstrates that it doesn't actually understand. And this is very, very true for large language models right now. There's a lot of examples of just throwing it the tiniest little curveball and it just completely throws it off its game. Like, for example, if you give it like a word problem and you throw in an extra piece of information that's irrelevant, it does really, really poorly. This is giving fodder for the haters and the fanboys. And some people, if you look at my recent videos, you might think I'm a hater. I'm not a hater. I think I'm a pragmatist, and I think that there's real world value with AI. There definitely is. It goes beyond chat. It goes beyond AI agents, and I think it will fundamentally transform a large percentage. Almost every part of every business will be touched by AI over the next 5 to 10 years, even if the models flatline completely right where they're at. But I also think that some people are getting way ahead of the game in terms of their painting of this future of what AGI God. And that to me, I don't think there's really much evidence for that right now. Could it change? Yes, but I think there's a lot of evidence to suggest that we might be quite a bit further from that than we think we are. And I mentioned politics before. This is why politicians are constantly able to fool people with 70% of people think this and trying to post it, but it's like, well, how was the question asked? Who did you ask? There's a ton of different nuance to the data that helps you understand its meaning. It's the same thing for these evals. How exactly were these taken? How exactly were they analyzed? Or how do we know that OpenAI or Google or Anthropic didn't just train on the testing set? Like they could have just done that, or that just naturally, even if they didn't do it intentionally, 95% of the training set, the actual test is in the training set in somehow, some way. And also on top of this, razor thin margins, as I showed in Chatbot Arena. You have all of these are above 1300, and they're all kind of in, somebody comes along and goes, okay, OpenAI is the next, it beats out Gemini. Or I think there was a period where Gemini was at the top for a bit, and like new best model, and it's like, okay, it's basically the same. This is within the margin of error for lots of these models, and I would say that these tests, these benchmarks, these evaluations have a huge amount of margin for error. Okay, and I've covered some of these issues, so we'll go into this a little bit more. Make sure I get all of these angles here. Training on evaluation data. This definitely happens intentionally and unintentionally. So there's an idea that basically when a benchmark has been out for any significant amount of time, it becomes useless because it gets into the training sets. And this is a way to get funding. Here's a great way to get funding. Take one of the open source models, find a benchmark you think you can train it on, train the shit out of it on that benchmark, post on Twitter, I created a fine tuning, or I trained it on this. I trained this model. It's the new best model on this benchmark. Give me $500 million. That will work a lot of the times. Maybe not all the times, but that has worked and will continue to work. There's a lot of ways to fake this. I mentioned this before. The kind of people on Chatbot Arena, it's not your average person. So, and again, it's a narrow slice of use cases. And I did mention this before. Memorization is not learning or understanding. All of the tests have even math, even the ones that are very logic-based, have a certain amount of memorization in them. And you can almost always, this is why, again, in the Feynman example, where this was a college, some of these people, and this is very common, they memorize their way all the way through college, and they don't actually understand anything. And I'm not dissing these people. I'm not saying they're bad. I'm just saying this is a strategy that can get results in terms of getting grades and getting you to the next level. But it actually is not a real way to understand. And when you're put into real world scenarios, you're not actually able to think about the problem in a productive way. Versus what Feynman really wanted people to do was actually understand the principles, what I would consider to be fundamental principles. I think other people call it first principles. Really understand that this is what most of the tests actually measure, which is the memorization, and that it's regurgitating the memorization. And that's why it trains on so much data. Now, another way that I've been putting it that I still think is very accurate, which is It can create new recipes, but it can't create new ingredients. So sometimes what it does is it can remix the ingredients, like with the AlphaFold, in unique ways that's useful. But it's not actually creating new ingredients. And a very large amount of these evals only demonstrate a regurgitation of knowledge. And if we want to really take a step back, actually, this is really important. So, put your phone away. This is actually one of the most valuable things that is almost never talked about with regards to AI. I don't actually see anybody talking about it. It's a fundamental piece to how the AI works, and I think it helps understand where the technology will go and what it's possible with, which is to understand that what they've done with these models is they've been able to, and it exists outside of the large language models as well. They've turned the meaning of words, be it a small chunk or a large chunk, into math, and these are essentially vectors, which you can think of as like lists of numbers that are pretty long that measure, okay, how related is it to this? How related is it to this? I've got my old, from my grad school, my old linear programming methods and applications book right here. Very nice book, by the way. I enjoyed it. I need to read it again. But essentially what they're able to do, it's in combination with this, when you take two of these vectors and you multiply them together. Now there's a variety of different ways to put them together. There's cosine similarity, and there's a few other types of similarities that give slightly different answers. But in general, this will tell you how close semantically two chunks of text are. And this is fundamental to how the LLMs work. And this helps you understand how it is able to, when you give it a problem, it's able to it's not crawling, but it's kind of using the most relevant parts of its data set to answer that question. So if you give it something that's in this part of the data set, this part of the data set, and this part of the data set, even though those typically aren't connected, it can connect those dots and come up with what appears to be somewhat novel answers. But really, basically what it's doing is it's regurgitating the knowledge, or to put it a little nicer, it's recombining already made ingredients into a new formula. And so this, to me, is one of the biggest challenges with all the benchmarks, that they are largely representing memorization, which isn't actually understanding. Again, going back to the awesome Feynman book. Anyway, that's what I've got on this. I appreciate you. I think O1 is very cool, and it's definitely in a lot of ways a move in the right direction. Keep in mind that it is not just a model, it is also a process, because basically they fine-tuned an 4.0 version of the model on reasoning, and they're putting it in chain of thought loop. That's the core of what they're doing. So it's not just a model, it's a model and a process. And so it's not really comparing apples to apples, it's more like apples to strawberries. So that is a key factor as well here. A little bit of cheating, a little bit of not fair comparisons. I do expect that Anthropic and Claude will catch up very quickly and have something like this for themselves very shortly, because this is chain of thought has been known about for 2 years plus. Well, thank you very much. If you like this video, please like and subscribe for more awesome content. I'd be really happy to hear what you think. Even if you disagree with me, happy to hear your thoughts. Also, if you agree, happy to confirm my bias. I'll try to respond to everybody in the comments. Thank you very much, and let me know what your experiments are like, or what your experience is like with O1. Have a great day. Bye.